So welcome back. We are today going to talk about GitHub version control, basically how you work on projects on code using Git and GitHub to make sure that all the work you do is getting logged and tracked, monitored, archived, and published in a way that other people can see. So these are what we're using the tools Git and GitHub for. In the general category of version control, talk about what version control is, why we use it, and then particularly about Git and GitHub and how those may be compared to some other version control systems, just in a high-level way. So let's get into what version control is all about. There are many different reasons why people use version control software like Git. Very often you need to roll back to a version of your project as it was a week ago or as it was a year ago. You know, you might work on some code but realize that the pathway that you're going, the decisions you've made were poor decisions, or you've learned as you've gone that what you're trying to do is just not working, and you want to go back to the way the code was at an earlier state. For this reason, version control keeps versions. It keeps snapshots of your project at different points in time. Your version today is different from your version yesterday, and you'd be able to go back and forward in the timeline of your project by using a version control system. Another need that we have in projects is synchronization. Multiple developers are working together, and that will be the case in any software project of any quality. Many people working together on a project. As we've seen, there are many challenges in software development. It's complex, it's abstract, things aren't what they usually are in most kinds of engineering. And so for that reason, we would want to make sure that some of these complexities are taken care of, and one of those being syncing up different people who are working together on the same project but may have their own copy on their own computers of the same project. It used to be you had to kind of share files by sending them around an email or some kind of file transfer program, and Git is essentially a file transfer program. One of its capabilities is that, as is any version control system. If you follow a particular workflow with a version control system, you can make it easy for everybody to have a common access to a public version of the code that is the authoritative version of the code at any given moment. There's an agreed upon authoritative source of that code so that everybody can see. If you want to get the latest, we all know where to go to get it. As we said, kind of in archiving, when we talked about just archiving, keeping versions of your project, one of the use cases for that is repairing a project that has gone wrong. So I already mentioned this, but rolling back to an earlier version. One of the main use cases for archiving your project is so you can roll back and repair, undo some of the changes that you've made. It used to be that developers would save different copies of their project with different timestamps in the file names, right? Like, here's my app _ September 1st, 2021. Here's my app _ September 23rd, 2021. We don't do that anymore, right? So unless you're working on something tiny where that's fine, just yourself on a small project, sure, go ahead and do that if that's easier for you. But generally speaking, today we use version control, so we don't have to do keeping file system files that have different names on them for different dates. That is an old-fashioned way of working. Another major feature of version control, which maybe is overlooked often, is accountability. In the world of software development, and particularly the disciplined approach, the software engineering approach, you want to know who's doing what, who is responsible for what, who agreed to do what, right? Remember that developers are kind of self-organizing in Agile. They decide kind of on their own how to work out the project. And when they're taking tasks that need to be done in software and deciding to work on them in a given sprint, one of the things we have to do in the sprint planning at the very beginning of each sprint is figure out who's doing what, at least the initial idea of who's doing what. You can swap around tasks, sure, in the middle of a sprint, go ahead. But we need to have some accountability, some designation of a certain unit of work being done and assigned to a certain person. And we need to be able to see who's not pulling their weight and who is pulling their weight. So you're being monitored. You're all used to being surveilled in every part of your life in other places. Here we're going to be surveilling you in the code domain as well. So by using version control, by making changes to the code base, by archiving them in the version control system, you will be logging and kind of stamping your name on certain changes. So every change you make that is logged in the system is logged as you. We'll be able to see who did what. So if somebody wrecks the app, well, there's no mystery who did it. We'll just go look in the version control system. Who made those changes? Boom, we know who you are. Right? There's no anonymity now in this world. And not only that, but we can start to get a sense of the tempo, how different developers are working, who's doing it quickly, who's doing it slowly, who needs more help because they're not doing much versus who's just plowing through stuff, right? So there are many positive aspects to this, but it is a surveillance system that managers will use to see that the developers are doing their work. So again, there's kind of no hiding from your productivity here. Everything is being logged. Experimentation is something that we embrace. You want to try out a new path in your code, a new idea, a new feature that you're working on, a new bug fix that you're trying to knock out. You might try things and you're not sure if it's going to work, right? But we don't want the experiment, the idea that I'm going to attempt to do something to make a change. And if it doesn't work out, we don't want you to have all kinds of problems going back to the version you had before you started working on that experimental change. We want you to be able to repair, go back to the earlier version, ditch your experiment if it goes wrong, go back and try it a different way, right? So we have in Git and other version control systems, some of them anyway, we have branching, this idea that you can actually split the code base and leave the main code as it is, don't mess it up, but try out this experimental version. And if it doesn't work out, you just slice off that branch and you go back to the main trunk. So we have various systems in version control to make sure that trying out code doesn't cause irreparable damage to the project. Let's talk about some terminology. What is a repository? A repository is a code base, essentially a database where all your code lives, and that's called a repository. And we can have two places where that repository lives, either locally on your own computer, on the computer in front of you, that's where the code is sitting, or remotely, which is on a server like GitHub. So post it up somewhere on an online resource. So those are two places the same code could live. Each developer might have a local copy, but there also might be this remote copy that is shared on a place like GitHub or some other online tool where you can post code. So it's on your own machine and you track your work there. Now, the remote is on some other machine, and usually that is kind of as we mentioned earlier, the central authority of the code. If there's code any one developer wants to share with the others, they push it up to the remote repository, which is an online accessible resource that other developers can access and download code from. And that's the way you share. I send my code to this remote server. Other developers grab from that remote server to get the latest. All right, let's talk about the trunk of the code. The trunk of the code, that shouldn't be big font, but the trunk of the code is the main version of the code that everybody agrees is so far the best version. As I mentioned earlier, you might try experiments or you might try bug fixes or extra features that you're working on in your code, meaning you take the main line of code, which is what we call the trunk, the version, the best version as we know today, and you might do a spin-off version, what we call a branch, and work on that and try and work out some new features. If that works out, you then make that the trunk. You take your changes you made in that branch and say, okay, that branch is now, boom, what we consider the new trunk. If those experimental bug fixes or features don't work out, well, chop off that branch, go back to the trunk as you knew it before, and continue from there. The value here is that everybody knows where is the latest, greatest code. It's always in the trunk. Anything in a branch is experimental, may not work out, may be chopped off at a later date. So we don't tell people that's the best version of the code at this moment, but it may become the best version later. Branches are the variants, the experiments, the trial and error kind of spin-offs from the main trunk line. File versioning versus repository versioning. There are different kinds of version control systems. You might eventually hear about other kinds. I just want to give you some high-level ideas of where Git fits in the ecosystem of different version control systems. There are two types really at a high level. A file versioning system keeps new version numbers for each file. So let's say you have 3 files in your project. If I change file number 1, the version number of that file is now like 1 greater than it was before if I make a new change, whereas the other 2 files stay at the version number they were at previously. So you might have different files at different version numbers. So in that kind of a world, if you want to roll back the code to an earlier version, it's a bit more problematic to roll the entire project back to an earlier version. You would have to actually kind of roll back each individual file to an earlier version because they're not all going to be at the same version number. They're not all in a consistent version number. Different files have different version numbers because when you change them, only the one file you changed gets a new version number assigned to it. Repository versioning systems take kind of a snapshot of the project as a whole. Every single file, it's like marked at a certain version. And if I change just one of those 3 files, the whole project, all 3 files are now at a new version number. So when you want to roll back or forward in the history of the project, it's easy. You roll back to a certain version number, and all those files, no matter whether they were changed or not, are now up to date at the version number you've settled on. So these are 2 approaches to the management of version control. In file versioning, the benefit is it's easy to find the history of all versions of a given file, right? You only have new version numbers on files when that file has been changed. So it's easy for you to roll through the history of one single file. And drawback is it's hard to figure out what the different versions are for all the different files that together make one version of the overall project. Repository versioning, taking snapshots of the whole project as a whole, and that's your version of the project. That's easy to find all the files together that make up one version of the entire project. but difficult perhaps to see the history of an individual file and roll forward and backward in just one file's history and see when those changes were made in that one file. So because every time any file changes, they all get assigned a new version number. All right, so these are the considerations, a little bit of, which kind you choose. And generally speaking, repository versioning is the latest, greatest in this world. Another way of kind of slicing and dicing version control systems is whether they are centralized or distributed. Centralized version control systems like Subversion would be one example of this. You have one server, one computer that has the single authoritative copy of the code at all times. Any other version of the code on any local developer's machine, let's say, is not the authoritative done version and cannot be the authoritative done version. There is no capability for that to be the case. In a distributed version control system, as is Git, you have no idea built into the platform anyway, no idea built into Git of which is the authoritative version of the code, the one that everybody should say is the right one. Remember, I just said earlier that we use GitHub, we use our remote repositories as a kind of authority, and especially the trunk branch in the remote repository as the authoritative version, the best version of the code at any given time. But that's not built into the actual version control system. That's a usage we use. We apply that rule when in our workflow. We agree we're going to work in such a way that that remote repository acts as the authoritative version, but that's not a fundamental feature of the version control system itself. That's a convenient way that we use it. Whereas in the centralized version control systems, that is built into the system's logic, the system's capabilities. Only one version can be considered the right version. In Git, it's possible for two developers to exchange code directly, not having to go through a remote server, but just treat each other as remotes and exchange code directly. We don't need GitHub. We can all just swap code directly in Git, and there's no one place where the authoritative version of the code lives. It could be just completely decentralized and distributed. Now, we don't often work in that way, but that is a capability of Git. That is not a capability of a centralized version control system. So what are some of the version control systems you might hear about? There are many more, but CVS is a centralized, we're not talking about the pharmacy here, is a centralized version control system. So that's where it fits into this scheme. There's one authoritative server that has all the code as we know it today, and anyone else just has a weak, unreliable copy of that code. Subversion, also a centralized system that was very popular until quite recently. CVS is a file versioning, so each file has its own version number. Subversion is a repository versioning system. So you just see kind of different version control systems mix and match, centralized, decentralized, file versus repository version. Distributed systems, well, really Git, I'm just going to focus on Git. There are others, but Git is the standard, the gold standard today. And that's it for our high-level view at version control system. We will get into a granular view of Git and GitHub at this point. Git is debatably the world's most popular open source version control system. I think it's probably, it's hard to get stats on this. I tried to find reliable stats, but I think it's probably the most popular, not just open source, but the most popular version control system just flat out. But I can't prove that to you, so I won't claim that that's true. All right, so it is a distributed system. You don't need to have that central server. You don't need to use GitHub. You can use Git without GitHub. Microsoft, which runs GitHub, would love you to think that you need GitHub, but you don't really need GitHub. It's convenient. Yes, we all use it, but you don't really need it. You can just exchange directly with other developers your code. It is a repository versioning system, so you have the version numbers associated with a snapshot of all the files together that make up each version, not just one file having its own version numbers. Created by Linus Torvalds, which people inexplicably love. Linus Torvalds, just I think because he's Finnish. I don't know why everyone loves him. He's made some very objectionable comments in the past at various times, and but yet he's got this kind of friendly demeanor. But anyway, he is one of the key kernel developers, or he is the key kernel developer of the Linux operating system. So, of course, one of the most well-reputed developers in the history of computing. He is the one who has actually started the Git project. What is GitHub? So GitHub is a free hosting of public open source projects. It is now just completely free for private projects as well. When I made this slide, that wasn't the case. It was acquired by Microsoft for $7.5 billion a couple of years ago, and that's pretty much it. So we're going to be using it as our central kind of server. Of course, Git doesn't require us to have a central server, but we will be using it for that purpose because it's convenient. Git follows a 3-tier model, and the terminology here or the workflow can be confusing for people. So I just want to kind of lay out how it works. You've got three places where code is being kind of stored and archived and tracked on your computer or on a remote computer. Whichever computer is running Git, there are three separate kind of storage facilities for the code. There is what's called your working tree or working copy. There's your staging index and your repository. And code will live in one of these three places or even multiple of these three places at any one time in your project. That's on one machine. We're not talking remote server versus local server. Let's just imagine your own machine, your own local copy of the code. You have three different tiers at which the code is being tracked. And you'll have to know a little bit about this just to use. What is the working copy? The working copy are the files that you're familiar with every day of your life on your hard drive, right? So you're dragging and dropping files, making files, deleting files on your own computer. The file system as it works, as you're familiar with it, that is what we call the working copy. Those are the files you work on. Those are the files you open up in your editor and write code in. They are not tracked by Git. They're your normal files. And so imagine you had a couple files, file 1, file 2, file 3, and a couple directories, directory 1, directory 2. Imagine that's our project. We've got 3 files, 2 directories in our project folder. And we're just working on those in our editor, putting some files in there and editing them and making code or whatever we do with our files. So those would be by default in the working tree. The staging index is where you put files that might be included in the official history of the project. Remember that Git, as a version control system, is going to take a snapshot of our project at a given point in time. It doesn't do that until you tell it to do that. It doesn't just track the files that you're working on. The files that you're working on are not by default in a snapshot. If you might want to make a snapshot, you might want to say, here's a new version. Let's keep a track of this one. Anything that you think you might want to put in that official history goes into the staging index. So again, if you're working on a project and you think that, you might want to track the changes you made to file 1 and file 3 in directory 1, and make a new version with the changes you put into those files, but not any changes you made in file 2 and dir 2. If you want to just make a version with the changes you made in these 3 things, well, then you would add them into the staging index. They're not yet officially part of the history of the project. They're not yet in a snapshot in a version, but you've said you might want to put those into a new version of the project. And you do this with git add. So this is the command you use. When you're just working with a working copy, you don't need any git commands. But once you're ready to say, okay, I might want to put these into the official history of the project, you have to explicitly add them to the staging index with the git add command on the terminal. We'll see Visual Studio Code has features to do this for you with a button click, but you could also just run the terminal command git add, and then whatever file or directory you wanted to add into the staging index you'd mentioned here. If you just put the current working directory, which is what dot symbolizes, as I'm sure you all know, that just means all the changes you've made in this project, basically everything in this directory on down, the file tree, everything that you've changed, put into the staging index. That's usually what you want. You're just going to take all the changes you made, put them all in the staging index. If you wanted to only put one directory or one file or a couple files, well, you can put something besides the dot. You could specify a file name or a directory name to add that to the staging index. But your typical workflow is just everything I've changed so far, dump that into the staging index to prepare for putting that into the official history of the project as a version. Again, you could specify a file name for if you just wanted to put one file or one directory into that project. The repository then, the next level of the 3-tiered system, is the official history of the project, right? So if anything has been put into what we call the repository proper, it is now a logged, versioned snapshot of the project at a given point in time. So when you make a new repository version, you're taking things that you said should be in the staging index, the things that you added with git add, and you commit them. You do the git commit command, and now, boom, you've got a new version of your project logged, tracked by Git, and stored in the archive. And that's the git commit command. So you would do something like git commit. This assumes you've already added something to the staging index. This wouldn't work if you haven't yet added anything to the staging index. There's nothing to put into the repository, right? So you have to have first staged with git add, and then you would take anything in the staging index and commit it as changes you made in a new version with the git commit command. And you have to leave a message, some short single sentence or a couple words message for you when you look later at the history of the project, some kind of a description of what you changed. What's different about this version at a high level compared to the last time you did a commit. So that's the way you'd use Git, right? So you make some changes in the working copy as you normally do with files. When you're ready to kind of make a version, you add, you do git add, and whatever you changed, add into the staging index, and then commit with a message. So if you look at the history, you'll see the message describing the changes at each point in time that have been snapshots of the project. The thing that seems to throw people off, is just the staging index. Why do you need it? Why can't you just take what you're doing in your working copy and just dump it into a new repository, which is usually what we want, but not always. You might want to selectively filter which parts go into a new version. Maybe you changed file2 and dir2, but those changes are no good. You're not sure about them yet, but you still want to log your code as it is now. Well, you can selectively add into the staging index and then make a new repository version that only includes the changes that you've made into these three things and not those other two that you're not sure about yet. So it provides the ability for you optionally to pick and choose which things that you've changed to put into a new version. Let's just talk about a couple of terms in Git. You've got clone, fork, master branch, remote, pull, push, merge, fetch. Lots of terms that you hear people talking about, and plenty of discussion boards on Stack Overflow, going hundreds of pages about all the differences in these different terms. Let's just talk simply about what they are. When you clone a repository, you make a copy of it. There you go, done. So that's it. You get a copy of a repository, meaning a tracked, versioned code base. You get a copy of that. All the history, all the archives, all the versions of that project, you get copied. One of the nice features about clone is that the new repository, the copy that you make, has built into it an understanding of where it came from, meaning a pointer, a URL, that points to the repository that it came from, that it was spawned from. So when you make a change to your copy, your clone, you can say git push or something like that, and it'll by default send those changes to the other repository. So you can actually very simply say, hey, I changed some stuff, boom, here you go, take it. And the other computer where the original repository was hosted will get your updates and potentially include them. So it maintains this link to what we call by default the nickname given to that other server or the other computer where the code came from is the origin. So you get by default ability to simply use the nickname origin, and Git has programmed understanding that that's the other computer where this code came from. All right, so if you clone, you can do that on the command line, a simple technique. If your code is hosted on GitHub, you can say git clone, give it the URL of where your code is hosted on GitHub. When you go to GitHub on the website and you view any repository, you can copy this URL, paste it into a git clone command, and boom, you get a copy generated on your own computer of that remote repository. Trying to kind of make this straightforward. So a new repository, you can have multiple developers cloning from a centralized remote repository. This is a centralized workflow. Remember, Git is by default a distributed system. It doesn't require the central authority, but our normal workflow is we do usually use GitHub or some equivalent server as the repository that we all refer to as the authority, and each developer can clone from there to get the code as it is on GitHub on their own machines. A fork is not a Git term. The Git technology does not have a git fork command. It's really just a fancy word for a clone. And it's not just any clone, but it's a clone on a remote server. So I can go to a repository on GitHub, I can click the fork button. I'm not making a copy onto my own machine, onto my own local machine. Fork makes a clone on GitHub servers. So it is a duplicate or a copy of the code, but on GitHub's servers under my own account. So I might go to your project, click fork. All the code repository of your project is now cloned on GitHub into my account. It's now under my control on GitHub. So for example, you've got, let's say, a couple developers. Developer one has a remote repo that they, let's say, are cloning from and working on. Developer two can say, go to this repository, click the fork button, and boom, they get a new remote repository that is in their control, copied. But it's on GitHub. It's a duplicate remote repository. So the master branch, or the master in Git, is a fancy word in Git for the trunk concept in just version control as a general set of tools. We talked about version control at a high level. The trunk is the authoritative set of code in the repository. Remember, you can have branches that are experimental, but the trunk should always be the best, latest, greatest version of the code. In Git terminology, that's called master, the master branch. Git treats all the trunk and branches equivalent. They're all treated as branches. And so the master branch is just the trunk in the world of branches. It's the default line of code. If you're going to copy a project and try and see what's the latest, greatest version of that project, well, the trunk typically has that. You could put it in a branch, but usually most workflows put the trunk as the master branch as the latest, greatest version of the code. Git doesn't require that. That's just the way we usually use it. So imagine you make some changes to code. You make some changes, you commit some changes, meaning you make a new version. You then over time work on some stuff and add some changes you made to the staging index, then to the repository. So you make another version. You then work on some stuff and you make a third version by doing a commit, right? That would be a kind of linear chronological sequence of the code changes over time. That's what the history of Git would be tracking. At any one time, the latest is the most recent set of changes you made and committed to the repository. And the authoritative version of that should be in the trunk. A branch is an offshoot. Experimental bug fixes, feature additions, whatever changes you want to make, you often do in a branch because you're not sure it's going to work. You don't want to corrupt your trunk. Your trunk is pristine, working, beautiful code. You try out new stuff in branches. And if they work out, you merge them into the trunk. But if they don't work out, you slice them off. So it is a offshoot of the trunk. So if I have, let's say, the first version when I'm here, this is time going to the right. If I'm at the first version of the code, I've committed and made a first version, you might try out some new feature. You add some commits to try out some new feature. So that's in a branch, right? You might make an offshoot branch where you try out some new stuff, see if it works. And if it does work, you'll merge it into the main trunk. But if it doesn't work, you'll cut it off. Meanwhile, other developers might be still working on the trunk and doing their own changes and committing stuff to the trunk, right? So by the time developer one, let's say, is figuring out their own branch, their experimental code, seeing if it worked, developers 2, 3, 4, 5, 6, 7 might actually be changing the trunk in the meantime. By the time the developer one is ready to kind of merge their good code into the trunk, well, that trunk has maybe changed. It's no longer as it was when they did their offshoot, right? So they're out of date. Developer one has a version of the code as it was in the beginning, but actually when they're going to try and merge in, put the code changes they've made back into the trunk, well, some other changes have happened since then. So what do you do in that context? We'll figure that out. But to do the branch, you do git branch. That shows you a list of all the branches that currently exist. If you want to make a new branch, you say git branch and then the name of the branch you want to make. So let's call this experiment one, right? Or new feature one or bug fix one, whatever you call it. You may give it a name. And there are rules that different teams follow for making these names kind of consistent. Pick your name, make a new branch. Now you've basically said, okay, I have a copy, an offshoot of the code. Changes I make in this branch do not affect the trunk. The trunk stays good code. Everyone can rely on that being the authoritative version, but I'm going to do this experiment in this other copy of the code. When you make a branch, you aren't working in the branch. You've made the copy, but you're not saying you want to work in that copy. So checkout is actually how you say, okay, I've made that branch. Now let's actually go make that the version of the code that I'm working on. So when you do check out a branch, all the files in your working tree, in your working copy, remember your regular files in your regular file finder or Windows file finder, update to the branch version. So whatever code is in the branch, you now see in your file finder. It might be different from what you had in the trunk. So you check out, meaning you make that your active working copy. If you want to flip back to the trunk, you say check out master. Again, it's treated just like a branch, but it's automatically called master. You don't have to make a branch called master. That is made for you automatically by Git. Okay, a remote is that remote other server that you connect to or other computer you connect to share code with. And as we talked about, origin is a nickname. If you do a clone, origin is a nickname that your Git understands when it's a reference to the original repository that you made a clone from. There's also the nickname upstream, and that would sometimes refer to the same place as origin, but it's just a nickname that's referring to a remote repository from which the origin repository was originally forked. So if you're doing forking, upstream refers to the original place that you forked from. So if you want to see the remote repositories that your Git repository knows about, so you have a clone, let's say, you want to see where the origin is, you do git remote-v, and that shows you all the remotes that you currently have, all the nicknames and all the URLs of the remotes that Git knows about, like origin. If you want to add a new remote, because maybe you have a couple different computers you shoot your files to and download your code from, your other computers you want to be able to have nickname kind of access to, you can manually add remotes, tell Git that there are other computers you want to be able to connect to easily. And you would do git remote add, and then the nickname you want to give it. Origin is a common one for if you're cloning, but you could just call this whatever you want, really. And git remote add whatever nickname you want to give some computer and the URL of that computer on the web. So that would now make a nicknamed other computer that you can easily push files to or pull files from. If you want to call it upstream, go ahead, call it upstream. Again, this nickname is your nickname. By default, when you do a clone, it creates the nickname origin automatically for you. But if you didn't do it that way, if you started the repository from scratch on your own machine, but you want to kind of link it up to a GitHub account repository, you could manually add in that origin nickname as if you had cloned it from that remote, even though you didn't really do it that way. Git pull, the command, will pull any changes or any new files or anything that's changed on the remote or your remote that you're pointing to, pull that stuff and download it down to your own computer in the current branch only. So if I'm in the master branch, or sorry, the main branch, I would do a git pull, and the main code from the remote repository, like github.com repository, would be automatically downloaded into my main branch on my own machine. Generally speaking, it's good to pull before you push. We'll talk about pushing in just a second, but it's the opposite. It's you taking the changes you made on your machine and shooting them up to a remote server. Hygiene-wise, it's good to do a pull before you push. We'll talk about that later. If you pull, you're downloading the latest in whatever branch you're in from the remote repository, let's say github.com repository, to your own machine. And multiple developers can all download from that authoritative source in this way. If you want to specify which remote you want to be doing the pull from, by default, if you've done a clone, the origin will already be set to wherever you cloned from. But if you want to explicitly say some other remote that you want to be pulling from, you can specify that here. Git pull from this particular remote, the one with the nickname origin, this particular branch. So you can specify some other branch that you're not right now by being a little more explicit. Usually if you've done a cloning kind of a way of doing things, you could just do git pull. But again, if you want to be explicit, you could do git pull from this remote, this branch. Specify some other nicknamed remote if you wanted to there. You've got a repository on GitHub that your whole team, is sharing. Your whole team together has a repository in GitHub that is the shared code that everybody can get access to. And let's say developer 1 put some code up there and developer 2 wants to download that code. Git pull, you specify git pull. If you want, specify which remote. If you have multiple, you can specify which remote with the origin or some other nickname you've made. And which branch, if you want to specify, by default, it'll be whatever branch you're already checked out on your own machine. But if you want to specify something else, you would put the branch name there. Pushing, the opposite of pulling, where pulling takes remote code and puts it onto your local copy of the repository. Push is the opposite. Take changes you made on your own repository, make sure other people know about those changes. Push your changes to some other server or some other computer. So it's the opposite direction. You're shooting code that you've changed and you've committed in your repository to some other computer, typically a remote repository like a repository on github.com. You could shoot directly to other developers, but typically you don't do that. Typically you shoot it up to GitHub and they do pulls to get it from GitHub. Similar syntax to the git pull. You can optionally specify which remote to shoot the code to. By default, it'll be origin, so you don't have to specify this, but you can specify origin. By default, whatever branch you're currently checked out in on your own machine, that's the branch it'll shoot the code to on the remote machine, but you can specify a different branch if you wanted to. So if you just do git push, it assumes the current branch and shooting it to the origin. Again, if you want to override those defaults, you can specify which remote and which branch. Again, if you had a different remote, some other machine, you could shoot it there like this. You would have to have, of course, a nickname in Git called upstream for this to work. If you didn't make a remote called upstream in Git, this wouldn't work. There's no built-in upstream. As we talked about, in a branch, you work on the code in an isolated offshoot. But if that code is going well and you want to merge it into the main trunk, well, how do you do that? But if both branches include recent changes to the same code, the same lines of code, Git will inform you of a conflict. So let's say I'm developer 1, you're developer 2. We're both working off of the same remote repository on GitHub. I download the code, you download the code. I start changing file 1, you start changing file 1. You finish your changes to file 1 and push it back up to GitHub. And now GitHub and you are at a ahead version of the repository compared to me. I haven't seen that you've made a new version and shot it up to GitHub, and GitHub has that version now. So I'm one version behind, but I make changes to the code also and then shoot those up to GitHub. Well, at this point, there's a conflict. You've made changes to that file. I've made changes to that file. Let's say we're even changing the same line of code. You wouldn't want me to just overwrite your version because I haven't even seen your version yet. And so there's an uncertainty as to whether Git should overwrite the file or not. So Git will inform you of that kind of a conflict. It'll pop up a message saying you have to resolve this conflict manually. So you have to manually go in. What Git will do is it'll pop open your editor and show you the competing lines of code, like the line of code I changed and that same line of code and your version of it. Git will show that to me. And I will have to, in my editor, manually figure out which is the right version or how do I combine the two versions to make it make sense. So a merge conflict requires manual override. The human has to go in and decide upon the final code that is appropriate based on what developer 1 did and developer 2 did. And both versions are then shown to you, and you pick which version, or you merge them yourself manually in the code. So that is in diagrammatic form. We've got the developer 1 who is, let's say the developer 1 is that branch over there. You've got developer 2 who is, let's say, working off in some other place that we can't see here. And developer 1 is making an offshoot, making some commits on their own computer. Everything works out really well, and they want to kind of commit back to the trunk. Well, developer 2 in the meantime has maybe committed a couple times, merged into the trunk earlier, and now developer 2's version is kind of out of date because it doesn't include the changes made by this other developer who made this commit. So again, that's the kind of the issue we're dealing with here, right? Which is, how do you go and in a logical way that doesn't interrupt other people's workflow, go and do that merge in a way that isn't disruptive to changes made previously by some other developers in the history of the trunk. There are various strategies people use. I'm not going to get into all the debate of which is the best one, but here's one that could work for everyone, I think, in almost all cases. As you do your merge, or before you do your merge, let's say, do a fetch. Get everything from GitHub that's in your project. All the changes other developers have made, just make sure you get everything. Before you merge, get all the changes everyone else has made. Switch to the branch that you've been working on. So yes, we download everything, but make sure now I go to the branch that I've been working on with some new feature or some bug fix. Get into that branch, make some changes to the code in that branch, do your thing, make that branch good. Then switch back to master, or main, as it's now called. Go back to the trunk. From the trunk, say to merge in this other branch that you made. Now, if you're done with your branch, you can delete it. And this is how you delete a branch. Git branch -d, give it the name of the branch you want to delete, and you now get rid of that branch. You've merged it into the trunk. You don't need it anymore as its own isolated offshoot. It's now embedded in the trunk. All the changes that were in that branch are now embedded. I should mention here that you should really do another pull while you're in master before you do the merge. Probably right between checkout and merge, do another pull just to make sure anything in master that you haven't gotten in that previous fetch is now included, and then do the merge. So the idea here is get the latest version of the code before you merge. Get the latest version from GitHub before you merge.